Yes, Ron, this is amazing. This is amazing. Shall we stop here? No, we're not. Let's just finish everything, right? Now we are talking about compound events involving complements. We've been talking about compound events all this time. We talked about independent events, whatever. We just saw how to deal with the compound events where we have the multiplication law and the addition law, and we use it all the time. But we saw how it changes a little bit when you meet independent events or exclusive events or whatever. Something changes, okay? We saw how for exclusive events, we know that the intersection, things that are mutually exclusive, we know that A intersection B is going to be 0. Okay, it's going to be an empty set, which means the probability of A intersection B was 0. We saw that. That was a special thing, that A intersection B was an empty set, and that meant that the probability of A intersection B is 0. Whenever you see it, you just remove it. That was for mutually exclusive. We saw the things that change, independent events, whatever. We saw that. Now here we are talking about compound events that involve complements. What is it? You'll be having something like this. B complement. And it is in here an operation. You can see that this is A intersection B complement. What does this mean? Well, this is an example of what we are going to have. We're going to have this, and we're going to have A union B complement. Now, what does it mean to say you have A intersection B complement? This is just that this is A is an event and B is an event, and they are in the sample space. Now we can say that when we say we want A intersection B complement, we want a special event, okay, which are the things that are in A but not in B. So it's like the event that A occurs without B. That is what we are looking for. The event that A occurs without B. And we can say this A intersection B complement is also just A minus B, okay? The event that A happens without B. And this is also written as A, then you put this slash, then you say B, okay? It means A without B. These are just other ways to write it, okay? Now here we'll be saying events A and B are in your sample set. So remember, they are in your sample set, but we are trying to find what is in A without being in B, or the event that A happens without B. We're going to see that, and we're going to see the A union B as well. Now, when we are going to be dealing with this complement, whenever we're going to be dealing with this, we're going to do this two separations, right? A intersection B and A union B complement. Now, when we are going to be dealing with these two situations, we are going to have two cases for each. This operation is the union or the or operation. This is going to be the intersection or the and operation. These two operations, when we deal with them, when we're applying them, when we want to find the solution, and we're dealing with A intersection B complement or A union B complement, we always see what case do we have. Because for each of them, we are going to have two possible cases. And for us to be able to know those two possible cases, what we are going to be looking at is, we are going to be looking at the idea of the things that, we're going to be looking at the things that cause something to be mutually exclusive and the things that cause it to be non-mutually exclusive. And that is what we want to talk about, okay? When we say we have A and BC being mutually exclusive, it just means, look at this. If A is a subset of B, this means that everything in A is also in B. Okay, so A and B may be exactly the same. They can be exactly the same size. If A and B are exactly the same size, everything of them is the same, then we're saying everything in A is also in B. And if everything in A is also in B, that means there is nothing that you find in A that is not in B. So that means if it's the situation is like that, that means you can never have something which is in A and not in B, okay? So what causes it? A will be a subset of B. And if A is a subset of B, then we're just going to say A intersection B complement, this is going to be an empty set, and the probability will be 0. And we know that when two events are mutually exclusive, that means their intersection is going to be an empty set, and their probability when you have an intersection is going to be 0. Probability is 0, but the sets themselves give you just an empty set, nothing, which means their probability is 0. You don't say the probability is an empty set. No, you'll be now saying their probability will be 0 from here. We know that. Now, what about if they are not mutually exclusive, A and things that are not in B? We want things that are in A, but not in B. That you're going to have something like that if A and B are not subsets. If A is not a subset of B, that means there are things which are in A which may not be in B. So this or when they are non-mutually exclusive, it means they can happen together. It means you can find things that are in A and not in B. And that means that A is not a subset of B. For that to happen, A will not be a subset of B, okay? And that means that you will not have A intersection B be 0. It will be equal to something but not 0. You get the concept? So these are important things, that the criteria we use in this section. If you want to understand this complement thing, we've seen that you're going to have event A and event B complement. Now, we see that when they are mutually exclusive, what happens is A will be a subset of B. In other words, you will never find anything which is in A and not in B. So you will not get anything. But if A is not a subset of B, then they are not mutually exclusive. They are non-mutually exclusive, which means they can happen together. You can find things that are in A, but not in B. Okay? That is what we'll be saying. And this is the situation. So non-mutually exclusive just means A is not a subset of B. Now, let's put some general things that we have to know, and then we start doing the cases. General things that you must know is that A intersection of A complement is nothing. If we say, please tell me the things that are in A and not in A, how is that possible? How can you have things that are in A and not in A at the same time? You can't. Either they are in A or they are not in A. So this is always 0, right? But now you must know that also, if we now have mutually exclusive events, then it is not only that, but A intersection B complement will also be 0. Will also be an empty set rather. For that is when you have mutually exclusive events. Remember that A intersection B complement is going to be an empty set, because every time we're mutually exclusive, those two events, when you find their intersection, which means when they both occur, that is going to be nothing because they can't occur together. Now that you know this, now that you have some basic background, some understanding of what it is that causes them to be mutually exclusive, A and B complement. Okay, so that will be A and B as subsets, not B complement. A is a subset of B, and that will mean that there is no way you find something in A which is not in B. So this is just going to be an empty set because A is a subset of B. The whole of A is also in B. Now, if A is not a subset of B, that means you can find things that are in A but not in B. That means A intersection B complement will not be this. This is not going to be correct, but it will be some set. There will be something in it. Now, let's start to do with our operations and let's see how we can apply this knowledge. Now, for our operations, remember, we are going to start by doing the intersection first. We want to see A intersection B complement. That is what we want to do, okay? Intersection, which is we want to see A intersection B complement. But we're going to see it for case 1, that is going to be for mutually exclusive events. For mutually, we want to see probability now. For mutually exclusive events, right? We want to see how we can get it. We'll be now just saying the probability of A intersection B complement is just going to be 0. Oh, really? Yes. Why is it 0? Because A intersection B complement, this is an empty set. So the probability of getting nothing is 0. You see, this is going to be, the probability of this is going to be 0 because they can't happen together. What is the probability that A and B complement will happen together? Well, if they are mutually exclusive, remember that it means A is a subset of B, right? Now, how can you have A being a subset of B and yet it has things things that are out of B? That's impossible. Everything in A is also in B. So this is just going to be what happens. I hope you're understanding. Now let's see case 2. Case 2 is for non-mutually exclusive. What does it mean to say they are non-mutually exclusive? Remember, we are dealing with A and B complement. Non-mutually exclusive now. What are we having in this situation for non-mutually exclusive events? We are saying that A is now not a subset of B. So it means that you can find things that are in A but not in B. So you can find things that are in A and in B complement, which means not in B. You can find them. So how do we now get the probability? You say, oh, this is intersection. So probability, you use the multiplication law. No. Not when you have complement. We don't use that. When we have complement, we don't use the multiplication law. You say, what? Yes, A intersection B complement. This is just going to be probability of A minus the probability of A intersection B. Then we'll have, so you want to find You want to find things that are the chance that you have things that are in A and not in B. You find the chance of A, then you subtract the chance of things that are both in A and in B. Then you have the chance of things that are in A but not in B. So if you say the whole of A minus those that are in A and in B, then you now have those that are in A and not in B. You want to find things that are in A and not in B, so take the whole of A and subtract the things that are in both of them. Then you now have the things that are in A but not in B. This is the formula you use for this. We do not use the multiplication rule. So this can also then show you that if you want to find probability of A intersection B, it will now also just be probability of A minus the probability of A intersection B complement. Remember this. This is how we do this game. That is only for the intersection. But for the union, we are going to use the addition rule and we're going to just slightly adjust it. That is for union. Yes, for union, we are going to use the addition rule. So in both cases, let's put for case 1 where A is a subset of B. So let's do for case 1. For case 1, we have them being mutually exclusive. So we can say A and BC are mutually exclusive. That is going to be our case 1. They are mutually exclusive. Why is it? It's because A is a subset of B. A is a subset of B, so you can never find things that are in A but not in B. So now how do we get the probability of A union not in B? What are we going to do here? We will just say this is going to be the probability of A plus the probability of B complement, but we will not say minus the probability of A intersection B complement. No, we know that the union rule says you then subtract, but remember that this is 0. Okay, so we can just say that the probability of A union B complement, we just say it's going to be probability of A plus the probability of B complement. That is what you do here. Okay, this is for case 1. Now what about for case 2 now? For case 2 where A and B complement are, this is the last one, are now non-mutually exclusive. When they are now non-mutually exclusive, how do we then do it? Okay, we will now say the probability of A union B complement. This is going to be the probability of A plus the probability of B complement, then minus the probability of A intersection B complement, like this. Okay, but now we know what this is. We've done this. We have talked about this guy. Okay, so let's put this in brackets here because we are going to put 2 important stages. So this is stage number 1. But we know this is just going to be what? We know that this is going to be probability of A minus the probability of A intersection B. Then we have the probability of A intersection B complement. We've talked about it. See, we just talked about it before. So we can now say that probability of A union B complement is going to be probability of A plus the probability of B complement. Then we say minus, we put, it's going to be the probability of A minus the probability of A intersection B. Okay, then we have the probability of A intersection B complement. Now from here we can simplify. We'll get the probability of A union B complement is just going to be the probability of A plus the probability of B complement minus the probability of A. Then minus becomes plus the probability of A intersection B, like this. Now what you must know, yes, this probability of A and the other probability of A will cancel because it's this minus. We have the probability of A union B complement is going to be the probability of B complement. Then it's going to be, this is going to be just they subtract, so it's going to be plus probability of A intersection B. Okay, this positive and this negative of course will cancel to 0. So now we will have, can we calculate the probability of B complement? No. If you're getting the probability of complement of just one event, then it is going to be probability of A union B complement. Remember we talked about probability of complement. We said, what is it? Is 1 minus the probability of B. Then we now have the probability of B complement. Then we can say now plus the probability of A intersection B. Then now we have this probability here and we would be done. So this is the one stage to remember, and here is another stage to remember. Okay, this is it. Here we are going to use the addition rule. Okay, we know the addition rule, then we just simplify it until we get here where it's 1 minus the probability of B, then plus the probability of A intersection B, and we will be done. This is going to be your final thing. Goodbye for now.